Okay, our first presentation today will be a journey to a pure IPv6 campus by Lowe's Srinivasan.
Hi. Good morning, everyone. My name is Log Srinivasan. I'm an engineering director at Cisco. Today I will go through a journey to an IPv6 only campus. Even though it is campus, whatever I'm going to discuss today or talk about today is going to be relevant to any network, be it service provider, data center, or any network of that sort. Right? So what we did at Cisco here is like, to give a brief summary, is like we picked a building in Cisco. It was a dual stack building, and we migrated that entire building into an IPv6 island and converted the entire set of users as well as like the network infrastructure to V6 only. That's the journey I'm going to talk about today. Before I get into the slides, I just had few questions while everyone is trying to assemble and so on. How many of you have a IPv4 or a dual stack network in your organization? Can I get a show up? Okay. Okay, that's probably around 40. I'm just estimating as such. And how many of you have a V6 only network in your organization? Well, that's good. They're like, okay, there are 4 is what I counted. So clearly, I think we have a long way to go for us to move into a V6 only organization. And that's one of the main reasons why we wanted to start this journey, to migrate a building into a V6 only network. So the agenda, briefly we'll go over the rationale for IPv6. This team will, this group of engineers will know this very well, but I'll briefly go through that. When you want to migrate a building from V4 to a V6 only building, there will be some roadblocks for successful adoption. We'll go through the roadblocks which we had encountered and what does it take for making it work. Then IPv6 readiness, especially even though it is like a first step towards IPv6 enablement, it's a leap forward for IT. And on top of it, like we'll go through some of the troubleshooting and the lessons learned which we had during this journey and the next steps. You with me so far? Okay. I'll take that as a yes. Okay. As you are aware of, we are running out of IPv4 addresses, and this is one of the main reasons we want to move into V6 adoption significantly across the globe. On top of this, we have few more reasons why we felt in our migration, why we need V6 migration. The key thing I would actually say is operational simplicity. What does it mean? Currently, if you look at the applications at Cisco IT infrastructure, they are currently running in VMs, and we are in the process of migrating them into microservices and containers. And in this process, we expect approximately 40,000 VMs currently servicing the applications which we have at Cisco, and we are migrating them into microservices and containers, and that will need to be approximately 400,000 containers. That's the IT estimate of how many containers will be there. And if you want to do this migration, we need to go to V6. Right? I mean, it's impossible for us to assign an IPv4 address for any of the containers on an ongoing basis. Right? On top of this, if you look at any traffic which is going into the internet, that is going through at least 3 to 4 layers of NAT. So that is another thing which can be removed if you go into a V6 network. And adoption of IPv6 so far across many organizations had been mostly dual stack implementation, and going into single stack will eliminate the complexity a bit, because you have the routers and the switches. When you do dual stack, they are processing almost double the memory, CPU, as well as the TCAM space which is needed for operations. Right? So going into a single stack will make it operationally simple. That's the rationale for IPv6 migration. Right? And in this journey, what is going on is like there are web scale companies who are migrating DCs into V6, and the logical next step is to get campus into V6 as well. And that's one of the reasons why we pursued with IPv6 migration of the campus. Okay. More with it, what are the roadblocks we will encounter when we are going for an IPv6 adoption? The first and foremost thing is like an end user mindset. As an engineer, when I'm accessing, let's say, a lab, I will do an SSH into 172.62.34.45. I'm just picking a number. I'm like doing a telnet or an SSH into a host, and in an IPv6 migration, it's very hard for you to do the telnet using the IPv6 long address. It's going to be quite difficult, so you need to move into a host name. Applications, one other thing we noticed is like all the applications are not ready for migration into V6. Engineers are used to tight VNC, and tight VNC does not support V6 as an example. And during the migration, we also found that like there are spots in the network. I mean, it was actually a surprise for us when we realized that our labs were totally V4 only. Then we had to find out a workaround for us to get that going. Not just that, when you're trying to access the internet, not all the sites are V6 ready. As an example, bbc.com, at least 3 months back, they were still V4. I believe even today they are still V4. And devices wise, Android devices do not support DHCP-V6, so we had to find a way to get them going to enable V6 in there for Android devices as well. So how do we make it work? We had like 3-step process. One is like 3 different areas we had to focus on. One is the IT transition itself, then the network validation, then the end user perspective. So we have a 4-step process for migrating this entire campus into V6. First step was to examine the network. This means what do we have in the access? I will have the next slide which will go through the details of the topology. For the access, we decided to go for a 3850 switch or a 9300, and for the core we went for a Cat6K, and for the wireless we went for a 8540 and wave 1 and wave 2 APs. Not just that, we had to analyze the traffic in the building, which means we had to find out what is the user profile. There will be engineers, software engineers, software developers, test engineers. You have like project managers and program managers, product managers. Everyone uses different types of applications. So we need to understand and identify the different applications which were in the building. Next is we wanted to validate the apps if they are V6 ready. For this, we had, most of the networks are, the network is already dual stack. Our network was already dual stack. So what we did was, in order to validate if the applications are ready, instead of migrating the network to V6, we enabled a V6 only SSID so that the applications could be validated. In this process, we found that like a good number of applications were not V6 ready, and for that we had to enable NAT64 and DNS64 for them to work. And on top of it, like for Android devices, we had to enable Slack and RDNSs for them to work as well. And as a third step, what we did was we created a V6 only data path, which means we created a parallel network which was purely V6 and without any V4 enabled out there, and we migrated about 100 users into that network. What this helped on is to identify the pockets in the network which were V4 only, which were not compatible to the V6 network. Labs was an example for that. After we did this, the final step which we took was to migrate the entire building into V6. Right? This wasn't like an easier process as such because we had to have war rooms to address any of the issues which came in on an ongoing basis. And I'll go through the challenges which we had in the war rooms and so on. Right? As I mentioned earlier, it's one step to IPv6, it's a leap for IT readiness. Right? This is the San Jose 23 building network. In here, you can see the access side. we had L2 all the way till like the distribution. 3850 4K is where the access, and 8540 is the wireless. And the distribution, that's where the IPv6 SVI is in there for termination of IPv6, and above that is the site gateway, which is V6 only. So any line here in this entire building is all, say, entire topology is all V6, and we had EBGP between the distribution and the site gateway. Beyond site gateway is where we had, like I said, like this is an island. So beyond site gateway is where we had like dual stack, and it connects to the corporate network. Right. We also improvised this recently. We put the latest and the greatest switches. I talked about 9300, 9400. We put it in the access, and then the core we added the 9500. Right. So what did we get into? What is that we accomplished at the end of the day, right? So we had 500 users in the building. Each one of them have like 2 devices at least, so that's about 1,000 devices. 3 floors, 6 wire-in closets, 500 plus switch ports, and 120 APs and 40 plus applications. It was a 3-month phased approach, which we worked together with IT organization, 2 engineers from engineering together with 2 engineers in IT organization. It's a 3-month process for us to phased approach to get this migration completed. What did this involve? We had, sorry, the slides went away. So, sorry, too many clicks. Yeah. So in the building, we had a significant amount of applications. Examples for VNC, remote desktop. I'm not going to go through each one of them, but I'll go through them briefly. Collab endpoints we had, which were running on PC, on laptops. We had like Cisco Spark, Jabber, WebEx, and the devices which were there in the network were like Mac, Windows, iPhones, Android, and enterprise services were like Cisco TV, AnyConnect, Telepresence, Proximity. Every one of them had a different set of challenge for us to get into a V6 only network, right? And the management part was like SNMP, NetFlow, and the network protocols which we used were like NAT64 and DNS64 and Slack, which we had to enable for us to get into V6 migration. The slides are okay. In this transition, there were few critical things as such. It was not just the applications. It was also the end user perspective is what we had to look at. We had to build in user profiles. Some of them are, anyways, the slide is not showing up properly, but that's okay. We had engineers who are in the resident in the building, who belong to different projects, as I mentioned. And not only that, even after we did the migration, we had visitors who would come in from outside, and they would have some issues in their applications as well. So we had to have workshops and dry runs. The dry runs which we used primarily were in step 1 and 2 and 3 in the migration process, and the war rooms were something which we had in step 4 for the migration process. So where we were in July 2016 is we had enterprises, they had dual stack. In our network, we had like an IPv4 based management policy and network policy, and the data path was also v4. Where we are now, we have enterprise products which are IPv6 ready, and some of the enterprise organizations are migrating into single stack, including Cisco. And in our building out there in Building 23 in San Jose, we have an IPv6 only network where the network policy, management policy, as well as like the data path is purely v6. We also introduced something called an IPv6 solution testing. That's pretty much to ensure that like on an ongoing basis, we are IPv6 ready. So that's on the journey as such as like how it went in. Now we'll go a little bit more deep into the IT readiness perspective of IPv6 migration. Right. We wanted to keep the building network simple. If you remember the topology diagram out there, we had L2 and then we had routing which was going on the site on the distribution. Then we had DHCP-v6 enable, VSS for redundancy, and primarily for wireless. So this is an example of the VLAN configuration which we had. We had 5 VLANs in the entire building. One for wired data, wired voice, wireless data and wireless voice, and also one for the APs. This is an example of a VLAN which was used on the switch for wireless data, which was mapping into an SSID called corp, the corporate SSID. And as you can see here, it says like no autoconfig. In our IT policy, we are not supposed to enable Slack. So by default, we had enabled DHCP-v6, and we had to disable Slack in the network. However, in the building, we also had users who are using Android, so we had to take care of them. So we had to create a hidden SSID Android v6 with Slack enabled, and that's the second set of the configuration. So the next thing is like how do you deal with IPv6 islands? So if you look at the small box, red box out there, and that's the building which we had converted. However, it is connecting to ENG labs. Labs were purely v4, and we had data centers which were like v4 and v6, and internet and campus core. I mean, everywhere is like dual stack. So it was super critical for us to enable NAT64 and DNS64 for the entire building to function. NAT64 and DNS64 was what was like holding it together. For this we used bind9 as a DNS server. So any query from the host will actually go to the bind9, then it gets connected to the corp, and you don't have to. So this was an add-on to the entire network together. You don't have to have a separate DNS server. Bind9 server had to be there as in the middle to get the DNS queries, and that goes to the corp, right? And ASR1K was used as a NAT64, and this is the configuration which was like used on ASR1K. It's actually pretty straightforward. So coming into the applications, we had a significant amount of applications, approximately 40 plus applications running in the building, and some of them were in this building. So in this slide, you can actually see that like there are applications which are green, which means that like they were IPv6 ready. Yellow means they were not IPv6 ready, and later on we got a revision or a newer version of it, and we were able to get IPv6 enabled. And red means we were not ready for IPv6, and we had to use NAT64 or DNS64 for us to enable, get them working on the v6 network. I'll briefly go through the troubleshooting and the case studies and the lessons learned. So here, one of the key areas I wanted to highlight is like real experience is what matters. We had actually done quite a bit of design on the network, and and anticipated quite a bit of things as like what needs to be, what are the different applications, how does it work, and so on. But real experience is what counts, and real impact of the app and services, we were able to understand it only when we enabled the network and when we got it up and running. Right. As an example, name-based access. Here it is not really technical, it is actually more behavioral. As I mentioned, IPv4 target host names where like, whenever they are host names, it's not a problem at all because DNS64 will actually do the translation, and NAT64 together, first DNS64 or translating to the v4 address and then NAT64 for it to go to the external world. That translation was easier, but it was more of behavioral. Like when engineers were trying to connect to the lab, they would connect to 172.16.32.1, and we had to have a mechanism for them to do the same thing in a v6 enabled network. So what we did was we had to create a script which will convert the IP addresses into domain names in a simpler fashion. So they will be very close. It will be like instead of a dot, they will use a dash, and they will be able to connect. These were the NAT64 and DNS64 issues we encountered. We were getting foray responses which were incorrect. It means like someone, when we try to access logs.com, someone had coded, some sysadmin had coded in their DNS server that it's pointing to a wrong IPv6 address. So the workaround was we had to exclude the prefixes other than 2000/3 for making sure like these are working. And on top of it, like when you have a foray query, if it returns a serve fail, it was causing a DNS64 synthesis failure. And for this, we had to artificially force the clients to go through NAT64 for them to get connectivity, right? Connect to the site, right? And few other things which we encountered. I mean, this is the thing I was talking about. The real experience is what counts. Sometimes it's like we can we had quite a bit of surprises out there. VMware Fusion was another example. VMware Fusion on Mac did not work with an IPv6 network with NAT64 translation, and we had to, in this case, we had to change the Fusion VMware Fusion node to a bridge mode and to make it work. And Oracle VirtualBox was another issue. We did know when we went into the migration that like Android we have to enable Slack, but when we went into the deployment, we realized that like Oracle VirtualBox also had this dependency. So we had to connect those users to a Slack network as well. Android, I talked about it. We had to have Slack enabled, and we had to create a separate SSID which was hidden for us to get this going. Not just that, even some of the internal messagings we had for softphone as well as like Jabber, we had issues as well. So we had in IPv6 we did not enable port 8443, which was needed for softphones to be working, and we had to work with the development team to enable that. So this is one of the things which I had highlighted as yellow. Where we found that like during the deployment it was not there, and after we got a patch we got it working. Other issue we had was like Outlook on the Mac. You will connect to the network, you connect to v6, and you will notice that like you will not be able to download mails. And it's because like we need to have 15.3 or above on Outlook for you to work on a v6 only network. So these are all like some interesting challenges which we had as such, because it comes only through experience. And on top of it, like I said, like we also had the war rooms. The reason why we had to continue that for a little bit longer than 1 or 2 weeks after the migration is because visitors will come from outside of the building. We had to have like a big placard out there which actually says like it's a v6 only building, and if you have any issues, go to this war room, or like an email address, because like someone will come from outside. Cisco's internal Mac, Outlook version at the time was 14.6, I think, and that was not compatible. So which means like anyone coming into the building will not be able to access emails. So it was kind of like a repetitive pattern out there. But the good thing is like we were able to get over it with war rooms, and we are now at a point wherein like we can say that like the building is functioning with v6 only. So what next? We are working with enterprise partners to enable more V6 only deployments. It's needed. It's super critical for us to go and deploy V6 across the board. And within our own organization, DC migration is important because like we have created an island, we have one island where we are able to work, but then like this doesn't scale because this is we need the entire ecosystem in the larger network to also be compatible. So we have a plan to migrate the DCs, and the DC migration will enable more and more buildings to be going into V6. And we had to change the development process as well. So we were at a point wherein like we were doing V4 first, and then we will do a catch up on V6, and that needs to change. So we have to develop V4 and V6 together, and that way we have a parity from the get-go when we want to go into V6 only deployments. And we are also working with a wide variety of application leaders in the industry for getting applications to be V6 ready as well. So net, I think the key thing I wanted to bring to this team is like V6 migration is doable, network migration is a part of it. The majority of the issues we faced in our V6 migration is primarily in the users and the applications. So network migration, you feel, I mean, like hey, V6 is simple and it's easy. You have a CCIE and you will be able to bring it up and running. So that was like the easiest part. Getting the end user perception as well as the application is what was very challenging, and we felt like it's important for us to share this with the larger team, and hope you would have got something out of this. More importantly, when you are doing a migration to a V6 only network later in the future, just remember that like it's not just the network, it's actually the users as well as the applications together. That's all I had.
Hi, my name is Lee Howard from Retevia. Thank you very much. This is fantastic. I'm glad to have the field experience report. Were there any applications that you had to abandon because they wouldn't work with NAT6.4 or V6 only?
Tight VNC.
Sorry?
Tight VNC. Tight VNC. We had to change it into real VNC.
Good.
So,
right. Yep.
So we had to give workarounds.
Yep.
Yeah.
And what's my other question? Go ahead while I look.
Hi, I'm Michael Osman with Coinbase. Did you encounter any operational issues with the Androids being strictly on Slack?
So once we enabled an IPv6 only hidden SSID, then we didn't have any issues after that. So we were able to sail smoothly. So the issue was more of like we have a Cisco ID policy where we don't want to enable Slack by default. So that was the reason why we had to go to a lot of InfoSec approval and security compliance and so on. And finally, like we came into an agreement because we are jointly working with IT that we will keep it as a hidden SSID for the Android users. But once we enabled it, it was okay.
Mind if I ask a follow-up question? Why is the preference to go with the HP v6 versus Slack? Is it for auditing and logging?
I'm not the right person to answer this question, but more importantly, so it's more of like you will be able to identify the user much easier when you have a DHCP v6. In a Slack, I mean, you can have you can spoof your Mac and you can get your own IP. So that's one of the reasons why Cisco ID does not want to do it, right? I hope that made sense.
Yeah, as it turns out, that was my other question.
Okay.
But I was surprised that you don't use .1x or network access control or something to do more thorough vetting of devices joining the network. But hey, you know, that's fine. It's your IT department. You get to decide that.
Yes, yes. So we didn't have .1x enabled at the time. So but that's true. We can actually enable it.
Hi, Hugo Slab at Demonware. Did you encounter any issues with NAT6.4, DNS6.4, and DNSSEC for the applications you're working with? Like, did you have to do like a break DNSSEC ES kind of thing, or were there any concerns?
So can you repeat again?
So were there issues where you encountered NAT64, DNS64 breaking DNSSEC that you had to, or with validating client resolvers, or did you not run into actual operational issues?
So there were a couple of examples I had given. Yeah. So those were the issues we had encountered, where like your DNS64 will respond back with an IPv6 address, which is not really a unicast IP address, and and that was the one issue we had. And with respect to NAT, we did not encounter much as such. Most of the issues we encountered was with like DNS64 translation, giving some address which is irrelevant.
But no DNSSEC specific things that there are like A's
no
only.
DNS site specific, yeah. At least in the enterprise side. So. I can take one more question. There's like a few, or we are out of time, is it? All right. Thank you so much. Thanks for the opportunity.
Okay, our next presentation will be Automating Device Certifications for Robot Framework by Pratik Lotia.
Good morning. So before taking a deep dive into the robot framework, I'd like to just ask a general question. How many of you are involved into some kind of testing, be it like feature capability or verifying the operational status, whether it's in a lab environment or production or something like that? Can I get a head count or something like that? Okay, that's 30% of the people. A lot of times this testing is done manually and feature by feature. So I'll be talking about how to use Python using robot framework to automate this certification. A lot of times there are several code revisions for different devices, be it a router, firewall, load balancer, and there are bugs in a particular version, and then our next version is rolled out. So before a version gets deployed into production, you just want to test the various features, whether the capability is working. Simple things like OSPF, BGP, NAT, whether they are working or not. A system which is already in production, whether it has the operational status correctly. So for example, the BGP neighbors are up, the counters are going on, so things like that. So starting with robot framework, it's an open source framework for acceptance-based testing. So for a particular test criteria, there are only two outputs. Either it is a pass or a fail. There is nothing in between that. So a test condition will either pass your acceptance criteria or it will fail. There are certain various vendor tools also available for automating the testing, but this is an open source one. It has some learning curve, but once you are into it, it is very easy to just write frameworks and automate your configuration. Pretty much like the name mentions, the robot framework, it's just like you tell it something to do, you supply the values or the attributes, and you expect this result. So it's pretty much like that. It's driven by keywords, so you just want to say, check whether BGP neighbors are up, check whether NAT is working or something like that. The underlying implementation is done using Python or Java, and the networking industry is definitely inclining towards Python for all types of automation. The ideal implementation is where the network automation engineers write the Python code for it, and the network engineers are just able to use those functions, put them into their framework, and then just run those tests. This framework is not specifically made for network-based testing. So if you go on the web and look for examples, it is difficult to find how you would find a way to jumpstart to write a generic framework. The good part about this is that it is data-driven. So the framework is very generic. You do not need to hard code any values in that. You can just supply variables, and that way you can use the same framework for different tests. It is also OS and application independent. So if you're using it on Windows, Linux, or Mac, it will work in the same way. However, the underlying Python code is generally not OS independent. There are some functions which don't work well with Linux and Windows, so sometimes you got to check that. So talking about the major components of the robot framework system, now you have say a server or a VM which you are using for testing, which has connectivity to a networking device like a router, switch, load balancer, or a firewall. The main part is the framework itself, which is a file with a .robot extension. It has certain dependencies and settings, parameters to define the configuration files, the variables, which libraries are being used. And then you have a series of test cases. Each test case has a keyword which defines what the test case is, what you intend to do, and then you supply the variables that you want to send to that function. It uses the underlying Python code for that. The functions inside the Python code are of the same name as that of the keywords. So if you're using a particular keyword in the framework, you need to have a Python function for that in the underlying Python code. It's preferable to have a generic function in Python because you don't want to get too detailed, so that you can use the same code over and over for different types of frameworks. You can have arguments applied to it so that you send it variables and it gives you the output automatically. Also, the Python function should have a return value. So this return value is sent back to the test case in the framework, and then you are comparing it with an expected value to the value which you got. Finally, there are pointers to configuration files. So for some types of feature, you want to load the capability, load the configuration, and then verify whether it is working or not. For example, the AAA feature, you want to load. This is the configuration for AAA, and then verify whether it is working or not. This is the structure of the framework. So you have your automation directory on your VM. We have the test suite directory, which contains several suites of test cases. Each suite has different test case parameters. So you want to generally separate the different test suites by the type of feature. So for example, all the routing capabilities in one single test suite, the switching capabilities in other test suite, the NAT stuff or the NTP stuff in a different test suite. There is also a resource directory. This is where you add the configuration files. So if you are into feature testing for a device, then you need the configuration files so that you can load it and then verify. If you're just checking the operational status of a device already in production, then you don't want to load any configuration. You don't need any such files. You just are verifying the status of different outputs. There is the library directory, which has the underlying Python code. You can have different Python codes and just point them in the framework itself, or have all the functions in a single Python code. Finally, there is the variable directory. It generally just contains one YAML type of file, so you have the different variables and the values that they hold. So for different types of testing, only the variable file has to be changed. So you might want to change the IP address, the username, credentials, or something like that. Running the robot framework is pretty simple. You first install it simply by pip install robot framework, and then you use the robot keyword to run that robot extension file. After running the robot file, the good part about it is that it provides you a HTML-based report. It contains the details of how the test went, each test case, whether it passed, whether it failed, what exactly failed in that. So this is the format of the framework. the framework is, it has the extension of .robot, but there are 4 types of files you can use to define the framework. One is the HTML-based framework. The advantage of this is that it has a very nice, visually appealing file. It is easier to understand. It is properly separated. It has different HTML tags. However, the problem that I have with HTML files is it's difficult to find a good editor to edit the HTML files. The other option is to use tab separated values. So these are essentially like spreadsheets which are programmed, it's easy to program them because you can import values, export values from them, and the values are just separated by tab. What I prefer is the plain text version. As you know, Vim is the best editor, so it's easier to edit this file using Vim and just define the framework in a plain text format. There is also a restructured format available. Several Python documentation is generally written in this restructured format, which is a balance of like plain text and HTML-based version. In this, you have the Python code, the framework, the variables, all in a single file. This is the structure of the framework. It's very modular, which means that the test cases are defined in different blocks. So when when an engineer is even reading a particular test framework, it is easier to figure out what test case is being tested or verified. It contains the settings, which are like just pointers to what libraries are being used, where is the location of the configuration files. There's an option to do a pre-test setup. So for example, if there is a particular test which you need to include in all of your test cases, then you can include that in the pre-test setup. So for example, when we are using, testing networking devices, we always need to have that SSH session from the test VM to the networking device. So it's better to define that session object in the pre-test setup and then use that same session for all the test cases. Then there is the test criteria. So this contains several test cases, one after the other. You can include as many test cases as you want. Finally, there is the test cleanup. So after you've completed running all the tests, you just want to gracefully clear the session, close the SSH session. So you have a post-test cleanup option also. Then each test has a binary value. The output is binary. Either it's true or false, because either a test has passed or it has failed. Each test can have multiple functions. So suppose you're testing OSPF capability. So first you want to load that function, you want to verify connectivity, you want to verify the neighbors are up, you want to verify the counters are going on or not. So each test case can have multiple functions. And it's a top-down approach per test case. This means that if any test function in a particular test case fails, then the whole test case is considered as failed. This is a sample of the framework. So as you see, we first define the settings. You can define what's the documentation. Now, it's a good practice to just mention what is this framework being used for. Then you define the libraries. For example, here I've defined operating system, which is the built-in library used for several OS level functions. And then there is the reference to the Python code which was written. So that's also another library that you're using. Then you reference the location of the variable file, which is the YAML file where you've defined all the variables and their keys. Finally, we have the suite setup and the suite teardown. So as you see below, there is a section for keywords. So what you defined in suite setup and suite teardown, that has been elaborated in the keyword section. So first, you're just opening a connection, running some particular function. Next, you're setting the suite variable. So you're just defining that the result obtained in the previous line is being used as the variable sum result for all the test cases. You also have that suite teardown where you're gracefully closing up a connection. The test cases here are just two simple test cases. One is we are just fetching the interface status. So it just has two functions. One is it's some random function taking some attribute defining the return value in a variable called output. In the second line, it just logs that output to the console. So when you run the test case, you can see what was the output like. The second sample test case here is loading a particular configuration. So here, suppose you are running some particular function, again with some variables, getting an output. Second time, you're again running another function, getting an output. And the third time, you're just probably comparing the values of both the functions and checking whether the expected value is matching the actual output. These are the robot command options. So when you run the robot file, there are several options available to run. Well, some of them are setting the documentation. So for example, for a different framework, you just want to alter the documentation, or it's a particular different type of version that you're testing. You just want to make a note of it. You can separately add documentation using the command options. You can also set the report name. As I mentioned previously, it has a very good HTML report which gets generated at the end. So that can be also defined. You can define tags. So for example, certain test cases are like critical test cases. Some of them are just basic functionality checking. So you can add those tags to the test cases. You can rerun a certain type of test cases. So for example, in the initial troubleshooting that you're doing, you're running a series of test cases and maybe 5 of them failed. That might not necessarily mean that the feature has failed. Maybe there was a connectivity error or something like that. So after troubleshooting that, you just want to rerun those failed tests and not run all the tests again. And then you can also define timestamps for logging and things like that. So this is the style conventions used in the framework. As we saw, the variable is defined in curly braces preceded by a $sign. The function name can be separated by a single space, or you can have it all together. So for example, we have the check interface config. There are 2 ways: either you have a single space in between that, or just define it all together. For passing variables to the function names, so for example, we have the show interface function. You have at least 4 white spaces to separate that, and then you add the variables. This is how you would create a sample and a simple test case. The test cases are defined under the test cases section. The keyword, which means what the test case is doing, is essentially what you are trying to achieve and not how we are trying to achieve. So for example, you're just checking the VLAN status. So we just mention show VLAN status. You don't need to mention how you are doing it, what attributes you are checking. So for example, here we have this function called copy file. Sometimes the arguments are mandatory, sometimes they can be default. So for the copy file function, you need at least 2 arguments to define what file is the source and what file is the destination. To create a file for this function, some of the arguments are optional. So you need to define what file is being created, but the content and the type of encoding for the file, either it can take the default value or you can supply to it. This is the first example of a simple framework using the robot framework. So here we are just verifying the version info of a particular networking device, which is a Juniper MX box in this case. So here we have defined the variables. We are using the operating system, which is the default library, inbuilt library available in that. We are using the Python code developed for that. And then we are adding the test case. The test case, the first line mentions the variable connection n, which is connection enable. So first we are using the function mxconnect, adding the attributes like IP address, credentials, and the session object is being stored in the variable called connection enable. On the next line, we want to use this session object and just get the version info of the device. So we use the function mxverifyFacts, use this connection enable variable and get the output. On the third line, we have the output logged to console. So when you will run the framework, finally you will get the output on your console. Now the functions you use here are mxconnect, mxverifyFacts, and log to console. Log to console is an built-in function available from the operating system library, so you don't need to define that. It will know how to do that. For MX Connect and MX Verify Facts, you need to define what exactly that function will do. So that has to be defined in the underlying Python code. The variables used for this, which we added in the test cases, were like the IP address, the username, the password. So that is, as you see, it's just defined separately in a YAML file. And if you're running the framework for a different networking device, you just need to change these key values. Coming to the functions used in that test case, one is the MX Verify Facts, and second was the MX Connect. As you see here, I've used the Juniper's built-in library, which is the PyEasy for easy connection to the networking device and loading some functions. So the MX Verify Facts just uses the PyEasy library called connect.facts to get the version info, and the MX Connect is just the simple function, which is the device function. You add the attributes to it, and then you get the session object. As you see, there is also return values in this functions. So this return values are sent back to the framework. Running this file, this is how the output would look like. This is just a single test case. So we had the version info logged to the console. It logs all the information. Since it completed this test, it gives the output saying this test passed all the test criteria mentioned, and finally it provides the output files. As you see, there are 3 types of output files. One is the output file, which is in XML format, and the other 2 are HTML-based reports. One is just a simple report of the test cases, and the second one is a detailed log report. This is how the log report in HTML looks like. The best part is, it gives you a clear indication whether all the test cases passed or any of them failed. So on your left side, you see it's a green colored report which mentions all the test cases passed. It gives you statistics about how much time it took, where is the log file located, what test condition was being tested. On your right, you see a failed report saying, hey, a particular test case failed, and that's why the whole test report is considered as failed. When you click on the log HTML pointer, which is around the center of the file, you get a detailed report. So on your left, you see it gives details about what was the test case, what different functions were used, what function did specifically, whether it was requesting some value from the networking device, performing some operation. On the right side, it again gives you the same details mentioning what exactly failed. So as you see below, it gives the status saying it failed. The reason was mentioned on the last line, which was a connection authentication error. So that was not a problem with the networking device, but there was a problem with the network connectivity. We mentioned about sweet setup and sweet teardown, to have an SSH object defined to be used in all the test cases. So here we are using this sweet setup and teardown, which is the first is open connection to the Junos box. It's defined below and under the keyword section. So what we did previously in the first example, just connect using the session object to connect it to the box and use that session object for all the test cases. We are just defining it here so that it can be used for all the test cases. Towards the end of the test, you want to gracefully shut down the connection, so you use the disconnect function to close the SSH session gracefully. Also, initially while developing the framework, you encounter a lot of troubleshooting errors. It does not mean the networking device has failed. It just means that something was not configured properly. Perhaps the configuration was incorrect. Perhaps the way of verification was incorrect. The troubleshooting with robot framework is not very efficient. So when a particular test case fails, you definitely get the detailed report and you can look into what failed exactly. But most of the times you're working in a CLI type environment and you don't want to just switch to a GUI based to see what exactly failed. So what I do generally for this is use the logging module in Python. This allows you to have all the errors or anything like that directly outputted to the console. So when you're running the framework, it will directly give you what failed or what is exactly happening in that function. So there are standard libraries and then there are extended libraries in the robot framework. These are the set of standard libraries. The first one is the built-in library. This allows you to evaluate certain things, run with certain conditions. So for example, you want to run a test case only if a particular test, different test criteria is matching or not. You want to just match the output saying, hey, this should be true or this should be equal to 10. You can use the built-in functions for that, so you don't need to develop a separate Python code for that. The other is a process-oriented library. So this allows you to run different process, get process attribute values like the PID, switch processes if required. There is also a datetime library. So if you're playing with time values or something like that, you just want to, it's difficult to directly extract the time, convert it into the time version. So here you can use the datetime library to convert it to whatever you want, to add times, to subtract time or something like that. There is OS level functions. So this allows you to do something with file level or directory level stuff. So if you want to check the file size, whether the file exists or not, what are the number of files in a particular directory, then you can do this. So for example, if you're loading a particular configuration from a file, you first want to verify that the file is actually present and then take that file and load it into the configuration. There is string functions. So this allows you to do any changes to a particular string output. So if you get a particular output from a particular function, you want to just measure the size of it, convert it into like lowercase or uppercase, get the number of lines. So this is useful when you suppose you're testing the BGP status or whether the BGP neighbors are up. For example, that you have 50 neighbors in your show BGP statistics output on the networking device. So you just get the output and verify whether the line count is as expected, whether it's 60, 50, or whatever it is. There is a collections standard library which allows you to use any type of lists or dictionaries just like how you use in Python. So it allows you to combine various variables or something like that. There is dynamic input option. So when you're running the robot framework, if you want to have a prompt, like a prompt to just give the value dynamically, you can also do that. And finally, you can also take screenshots. So if you are into GUI-based testing, just testing whether the web UI of a particular networking device works or not, you can just grab the screenshots while running the test case and later just verify the screenshots are as expected or not. Then there are extended libraries because the built-in libraries don't do all the functions which are required. One is the Selenium one, which is definitely obviously based on Python. This allows you to automate with web UI options. So if you're doing anything with web UI, it's easier to use the Selenium library to identify what tab you are clicking, whether you are filling a particular input box with some values or something like that. There is also a library for pub/sub types of systems. Here it's the MQTT library. If there is a particular polling or something which needs to be done, you can use this library. There is a faker library. This generates random fake words or documentation or something like that. Just like in a documentation, sometimes we just want to, in documentation, we would just want to highlight how the documentation would look like, and we use those ipsum lorem or something like that to fake those words. Similarly, you can use the fake library here. There is the SSH library. So if a particular networking device does not have its own library for SSH, for example, most commonly we use netmiko, PyEasy, or something like that. But if a networking device does not have that library, you can use the SSH library and still run all your commands using that. There is a library for database. So if you're playing with MySQL, creating databases, merging something, you can use the database library for that. You can also archive certain files using the archive library. I mentioned about tagging previously, that you can set tags using the options. If you don't want to set tags using options, you can also define tagging in the framework itself. So for example, there are 3 types of tags. One is the force tags. So for example, here we have defined NANOG 74 as the force tags. This means that this tag gets applied to all the test cases, no matter whether you like it or not. So that's forced onto all the test cases. Then there are default tags. So here we've defined user1 and security as the default tags. So for a particular test case, if you have not defined the tags explicitly into that test case, it will use those default tags. So in the test case, we see for the first test case, just a sample test case, we have not mentioned any tags. So it will have the forced tag value, which is NANOG 74, and it will also have the default tags because you did not mention any tags. For the second test case, you're mentioning the tags like Canada and network. So it will use the force tags because it gets forced onto all test cases, and then it will use the tags mentioned here. It will not use the default tags here. So this helps to separate different type of test cases. If you want to have certain test cases critical, certain test cases specific to switching, certain test cases specific to routing or peering or something like that. So you can set those tags, and when you run the whole test case, when it fails, you identify what feature is not working. Using editors, I personally prefer using Vim. It's simple to use enough for editing the framework file, but there are all these types of editors available, Eclipse, Sublime. Some people still use Emacs. So you can still use them to edit the framework file. This is the example 2 of how the framework would look like. So here we have taken the example of SNMP polling. Here we are loading a particular configuration and verifying whether the SNMP polling is working or not. So in the first test case, there are like 8 to 10 different lines. Now at first, what we are essentially doing here is, before loading the configuration, we are just verifying that the SNMP walk feature does not get any output. So here we are setting the variable to 1, which is the SNMP version 1. Later in the function, we are also setting it to 2C, so we are checking the SNMP version 2C for that. What we are essentially doing is that we are running the SNMP walk function, supplying it attributes like the IP address, a particular community value, and the version value, and then getting the output of it. On the subsequent lines, we compare the output to the expected value. So before loading the configuration file, we would expect that the timeout, the output should contain a timeout response, because without the configuration, you won't get any SNMP polling. So that's what we are doing essentially before loading the configuration. In the last 2 or 3 lines of the first test case, first you see the file should exist. So when we are loading the particular configuration file, you're just verifying the file is existing. On the next line, you're loading the file and committing the configuration. And on the third line, you're just verifying whether the commit was done properly or not. In the second test case, we are verifying whether the SNMP polling feature worked or not. We are doing it for IPv6. So now we use those same test functions which we used previously. So like set variable SNMP walk. This time the configuration has been done correctly. So we expect that the output should not contain timeout response. Instead, it should give us certain value. So for example, here it should give like Juniper networks or something like that. At the end, you don't want this configuration to be on the box forever, so you just roll back the configuration. These are the variables used for that sample framework. We had IP address, username credentials, the SNMP IP address, the community values. One was the wrong community value, one was the right community value for checking whether it's working with the right one and not the wrong one. And then the location of the configuration files. This was the Python code used for that, so we just had to use 3 functions. All the other functions which we used in the framework were pretty much built in. So first is the SNMP walk function. As you see here, the SNMP walk function in Python, it uses subprocess to actually use the SNMP command in Linux. It gives the variables, the arguments for that. So like the version number, the string, which is a community, the IP address, and gets the output, returns it back to the function. The second function we used was the loading of the file and committing that. So it was the load, set file, and execute. So we used the Juniper's library to do that. So we just using the connection variable, which is the SSH object, which was used previously, and loading the configuration file into it, and finally committing it. The third function used here was the rollback function. It simply does the rollback on the configuration. There is also an option to add loops, and just like how we use loops in Python, we can use loops in the robot framework for if you have certain repetitive tasks to do. This is the syntax for that. However, I personally do not prefer using loops in the framework because it makes it messy, it makes it difficult to read. I prefer having all the logic in the Python code itself. These are some additional tools available with the robot framework. So, if you want to do something with the XML output that you get, you can use the rebot tool. You can merge different reports so that if you want to submit it to your leadership team or the executives, you want all the reports to be combined together and then sent to them. Sometimes I'm lazy. I do not write a lot of documentation inside the code. So you can use the libdoc feature to generate documentation. What it does is that it identifies the keywords used in that and automatically defines a set of documentation for that. You can also use dbbot. So this helps if you want all the reports sent directly to a SQL database, a SQLite format. So you can store all the reports together, merge the different reports in a SQL format. There's a very nice additional tool which is a robot coder. So if you're working with web UI or something like that, you don't want to write the framework from scratch. What you can do is that you can launch this robot coder tool. And what it does is that it captures all your GUI actions, what you did on the web page or the tool, and then it automatically generates a framework based on the actions you did. So you just have to run the test case once manually. It will automatically generate the framework for that. And then there are a couple of other tools for parallel execution of test cases. For example, if you have 80 or 100 different tests and you don't want it to take too long, they are not dependent on each other, so you can run them parallelly. There is also an API available to run the framework. It's kind of running code, using code. I have not really found a particular use for the API yet, but it's available. You can use all the robot command options, the additional tools, retrieve reports using the API, dynamically supply variables or something like that. This is the example 3 of the framework. Here we are verifying whether the AAA configuration is working as intended or not. So in the first test case, we are just loading the configuration file. So again, we are checking whether the file exists. Then we load the file, and then we verify whether it got committed correctly or not. In the second test function, we are verifying the AAA feature. So it's another networking device. We are using the router connect and the router show function, which was similar to the ones used on the Juniper, like MX connect and MX verify facts. So we just apply the attributes of the networking device, like what type of networking device is it, the IP address, the credentials, and then since it's a AAA verification, we are verifying whether a particular test user has the privilege to do configuration or not. For a test user, we want, here we are checking that the user should not have the privilege to commit a particular configuration. So we want the, we are checking the check enable status on the networking device, and we want that to be false. The next time, if we run the same function with an elevated user privilege, we want to verify whether that enable function is actually working on that or not. This was the variables used for that, which are defined in the separate variable file. Again, similar things like IP address, credentials, the test user credentials, the location of the file. This is the Python code used for that. So similarly, we had one function for loading the file and executing it, one function for actually generating the session object to the device itself, so connecting to that router, checking the enable status, the configuration status by using the check the router connect feature, and then the router show function where we were just verifying whether this particular user existed in the statistics or not. There are some do's and don'ts associated with the framework. You should try to not be lazy like me and add more documentation in the framework. After a month or after 6 months, when you're relooking at the framework, you should be able to understand what exactly you did or what some other person did. Also, I would not add too much of documentation, because then it makes it messy, and then it makes it too detailed to view it properly. The naming of the keywords should be short and easy. So essentially, we want to identify what we are doing and not how we are doing. So for example, we are loading the remote syslog capability. We don't need to define how we are verifying the whole feature. We just need to define what we are doing. You should also have uniformity in your framework so that it's easier to read. So here, since we have everything separated by tabs or spaces, you can identify what is the function, what variables you are passing, where is the output going. As I mentioned previously, all the logic, it's better to have all the logic in the code instead of having loops or something like that in the framework itself. It is data driven, so you don't need to hard code any variables in the framework. You can add all the key values in the variable file. Also, a particular don't which I want to mention is it's better to do polling instead of sleeping. So for certain type of functions, you might have to wait for 15 seconds or 30 seconds before you actually get the output. On our networking devices, if you are checking a particular show command status, it takes like sometimes 10 seconds to get the whole output. So sometimes you have to sleep the function for some time so you get the whole output of the show command. But instead of sleeping, you can what actually do is that do a polling, which is wait till the creation of a particular file, so that that helps to run the framework faster and not just have it idle or sleeping. This is the final example of the framework. We are verifying the packet loss and whether the SYN flood is getting blocked or not. So here we are using the hping, which is a Linux command tool for generating a simple DDoS type of traffic. Here we are sending a hping flood, verifying whether the packet loss is 0 or whether it is below a particular limit. Then we are actually loading the configuration so that it actually blocks the DDoS traffic. In the second test case, the verify SYN flood, we are using the same commands, the same functions again. We are again generating an hping flood, verifying what is the packet loss, and this time we are comparing it with the expected value. These are the variables used for that. Again, the IP addresses, the credentials, the location of the file. This is the Python code used for that. It uses the hping flood, hping packet loss, loading the files, and then a simple another function to check whether the value is greater than what is expected. I have got a demo of that. I'm not sure if I can play it from here. If someone from the team can play it. Okay, there we go. So this is where I was checking the different features on the SRX firewall, verifying whether syslog is working, NTP is working, the AAA is working. So once you load the framework, it will automatically let you know whether a feature has passed or failed. We see here a couple of features failed. This was in the initial days of the framework being built. So when it failed, it didn't mean that the SRX firewall failed. It was some problem with the configuration. You see the IPv4 and the IPv6 access capability being checked, the management configuration, the SNMP polling for V1, V2C, V3. So all this feature testing, which would generally take you days to do, once you've developed the framework, you can run this framework for any type, any particular networking device, and then you just get the output in like 5 or 10 minutes. As you see, it sometimes gives you details about why a particular test case failed. Some test cases do take a while, like 5 or 10 seconds to run completely. Sometimes they are polling, sometimes they are getting the whole output and matching to the expected value. And finally, we have the output files. One is the XML format, and other two are the HTML files. So this is the report. It gives you an overview whether test cases, whether all of them passed or failed. Here it shows that 5 of the critical test cases were failed, how much time it took, and then it gives you the option to go more detailed into the log file. So as you see, the log file gives a detailed, information on what test cases failed, what exactly keywords were run, how much time it took, what function did it do to the networking device. Same for a particular for a failed test case, it defines what exactly failed, why it failed, and reasons for that. So yeah, that's pretty much it. There's initial learning curve to understanding how robot framework will work and how you will develop it for a particular network device. But once you identify how to develop it, once it is developed, then it is very easy to automate the testing for all the several subsequent models for the same vendor. These are some helpful resources for that. And finally, I understand this was a very deep dive. It was too much for 45 minutes. So the slides are available on the NANOG website. If there are any questions, please feel free to contact me on pratik.lotia@charter.com, and we might have a couple of minutes for questions if anybody has. Thank you. All right. Yep, looks good. All right, thank you.
Okay, so this room will be closing down. The remaining presentations will be in the Plaza Ballroom that's downstairs. If anyone has any questions, please let us know. All right, thank you.